Hello everybody, welcome to the part 3 of electrochemistry. In this particular part, we are going to see about electrolytical cell. In the previous classes, we have studied about electrochemical cells, which convert chemical energy into electrical energy. So redox reaction is made use of for generating electrical current. And we also see how to measure the electrode potential and the various uses of electrode potential in determining the strength of a metal or a species. And in this part of the electrolytical cell, we are going to see what way electrical energy bring about the chemical change, and we will see what are the different ways of doing electrolysis through the electrolytical cell, what is the industrial application of this, and what are the products of electrolysis. Is there any way to find out or predict the product of electrolysis, and Faraday's laws of electrolysis to judge how much is being produced during the electrolysis, and some references at the end we will see. What are these electrolytical cells? So electrolytic cells essentially consisting of one electrolyte and two metal electrodes, which are connected to AC source, alternate current source. Here, the electrolyte which is being present, which contains ions, are undergoing a redox reaction. The species which are easily oxidized get oxidized, and easily reduced get reduced. So, in an electrolytical cell, there will be two electrodes. Electrodes may be active electrodes or inert electrodes. Inert electrodes, we mean the electrodes do not participate in the chemical reaction. If they are active electrodes, then they may take part in the redox reaction that is occurring in the electrolytic cell also. Let us try to see more about the electrolytic cell. What is electrolysis? Electrolysis, it is the process which electrical energy is used to drive the non-spontaneous chemical reaction. A chemical reaction which otherwise won't occur, made to occur by the passage of electrical current. And electrolytic cell, it is the device or apparatus which carry out the electrolysis. Right? And now the question arises, what is the difference between galvanic cell and electrolytic cell? Galvanic cell we have used for generation of electrical current consisting of two half cells. And metal electrodes, single electrode is present along with this ionic solution. And here also electrode is present with its ionic solution with a salt brick, and this is the arrangement. And electrons flow from anode to cathode. So two half reactions takes place in the galvanic cell. And in electrolytical cell there will be only one electrolyte, and both the electrodes will be dipped in the same electrolytic solution. And what about the E of the cell? E of this cell is positive in this case, whereas E of the cell is negative. It is negative in this cell. This is a spontaneous redox reaction, but this is reaction occur only when electricity is passed through. It is not spontaneous. And change in Gibbs free energy, that is delta G is negative. For spontaneous, delta G is negative, and for the reactions, this is delta G is positive. Energy is needed to occur. Now, let us see how to analyze the product of electrolysis. Then by taking some example, let us take the product of electrolysis depends upon two things. One is nature of the material and another one is the electrolyte. The nature of the material being electrolyzed and also electrodes. As I told you, electrodes may be active. If it is an active electrode, so electrodes may also take part in the electrolytic reaction. And also, it also depends upon the standard electrode potential of the species involved. The species which are involved there, their standard electrode potential is also responsible for predicting the product of electrolysis. Let us take some examples and see how exactly the knowledge of electrode potential will be helpful in deciding the preferred product at the electrodes. Now, this is the arrangement for electrolysis of potassium chloride. So, molten potassium chloride is taken as an electrolyte, molten form, melt form. So, it is kept under temperature, high temperature, so that KCl remain as in the molten form. Two inert electrodes are being taken, and when electricity source from the DC source is being passed, then the products are started forming. We find that potassium gets deposited over this electrode. Potassium, it becomes thicker and thicker due to the deposition of potassium metal. And here at this electrode, chlorine gas is getting evolved. You can see the bubbles of the chlorine gas. When molten potassium chloride is electrolyzed, we observe this thing. Right? So, a DC source is important because direct current is important, so that the polarity will remain as it is. Now, why this reaction occurs in this way? It is because this polarity, this is negative electrode. Negative part of this generator it is being added, therefore it is negative electrode. This negative electrode is called cathode. Here it is called cathode. And at cathode, cations will move. So in this solution, cations will move towards the cathode. Cations will move towards cathode and they get reduced. They get electron from the external circuit and they get reduced. And in case of anode which is positively charged here, anions will go to that and leave that electron, therefore they undergo oxidation, losing of electrons is taking place. So remember here, it is the difference between galvanic cell and the electrolytical cell. It is the sign convention. So negatively charged electrode is called cathode here, right? But whereas negatively charged electrode was called anode in electrochemical cell, right? So this is the, and one thing that you can remember commonly for both the cell is cations move towards cathode. Cations move towards cathode. This is the common thing. And oxidation always takes place at anode. That is also common for both the cells. Remember, oxidation takes place at anode. So let us see the reactions and the observations further. So, and what it actually happened is liquid potassium is produced at one electrode. Liquid potassium. So temperature is more, therefore liquid will be in potassium will be in the liquid form. And is the electrode is anode or cathode? The question to analyze. So by looking at the reaction, can you able to say whether it is a cathode or anode? Definitely, because the electron is gained here. This is the reduction. Reduction occurs at cathode. Therefore, this is cathode. And gaseous chlorine is being produced, as I told you. And this chlorine is being produced. Therefore, whether it is anode or cathode, since oxidation is taking place, this is anode. Anode is the one electrode where oxidation takes place. Right? Then, see, this reaction, cell reactions are depicted in this way. At anode, chlorine is get oxidized, and cathode, potassium is being formed, and overall reaction is giving chlorine and potassium. This is a non-spontaneous reaction that is going to occur when electrical current is passed through the molten potassium chloride. Right? So let us take some more examples to see what could be the products. Now it is the case of electrolysis of aqueous potassium sulfate. So I have taken another one, aqueous potassium sulfate. Aqueous potassium sulfate means potassium sulfate taken in water. Potassium sulfate dissolves in water and that is being taken as electrolyte, aqueous potassium sulfate. Now, if your battery is being on, then you can able to find hydrogen gas evolved at this particular electrode, negatively charged electrode, and oxygen is produced at positively charged electrode. Here potassium ion is not being taking part. So here there is a need of understanding why it is occurring so. So at cathode, if you take at cathode, what are the possibilities? What are the possibilities when electrical current is being passed? So potassium sulfate contains two ions. One is potassium ion and sulfate ion, SO4 2 minus. So these are the kinds of ions present when this is for undergo ionization or dissociation into ions. This is being produced. Now along with this, water also is consisting of hydrogen ion and hydroxyl ion. Water also will be consisting of H plus ion and OH minus ion, maybe to the lesser extent, but they are also present. Now at the cathode there are two competing cations. So there may be cation potassium or it may be hydrogen ion which is being present. Now potassium ion, if it undergo reduction, then liquid potassium is being formed, or potassium may be deposited because temperature is not more, therefore solid potassium may be formed, or two of the hydrogen ion taking two electrons, we will get hydrogen gas. So there are two possibilities. Out of this, we find that this is the only reaction occur at cathode. Only hydrogen gas is being formed. Now you look into the electrode potential values which will justify why hydrogen gas is being formed. If you see electrode potential values, reduction potential of potassium ion, since it is a very reactive metal, potassium is a very reactive metal, it has got a negative sign on the electrode potential value. Reduction potential is negative. And for the hydrogen, this is 0. Arbitrarily it is taken as 0 for the reference electrode. So standard electrode potential of potassium is negative, whereas this is 0. Therefore, reduction potential of H plus ion is more than that of potassium ion. So out of two ions participating in the reaction, this is going to reach the cathode first, or this is being formed, the hydrogen gas is being formed. So remember that at cathode reduction occurs, and the species which are being present in the electrolyte which has got higher reduction potential is going to be evolved at cathode. And now coming to anode. O2 gas is being formed. Okay, so which are the competing ions? They are sulfate ions and hydroxyl ions. So exactly, the hydroxyl ion is having greater oxidation potential than sulfate ion, therefore O2 is being formed. So we have to refer the electrode potential values for justifying the product. Right? See here, this is another way of writing oxidation of water. Oxidation of water, either you may write like this, or you may write H2O plus 2 electrons giving rise to H2 plus 2 OH minus. This is also the way of representation of oxidation of water. Water contains H plus ion and H plus ion undergo reduction. Okay, so this is the combination of two reactions, you can say. H2O giving rise to H plus ion and OH minus ion, right? H plus ion and OH minus ion. If you balance, okay, it's already balanced. Now, in order to cancel this, you multiply this by 2. Now, make the overall equation from these two, H plus and H plus get cancelled. 2H2O, okay, this also to be balanced, 2H2O, right? 2H2O plus 2 electrons giving rise to H2 plus 2OH minus ion. So it may be written in this way also. Okay, so it is because of the combination of these two. H2O gives H plus and OH minus ion. From H2O, when H plus is being consumed, then H2 and OH minus ion will remain. So this is also being experimentally seen that near the cathode, if you see the pH value of the solution, it is basic because of the formation of OH minus ion. Now, H2O undergo oxidation, then O2 is being formed. So, very important thing to be remembered and very important thing to be practiced is when the H2O undergo oxidation, that means losing of electron. When it loses 4 electron, it forms O2 and 4H plus ion. It forms O2 and 4H plus ion, and this is the cell reaction. Let us see these reactions also in this. Okay, so solution becomes basic near the electrode and what is the cell reaction? Will you try? What is the cell reaction? Already I have written most of that, and gaseous oxygen is being formed at anode and the solution becomes acidic. This is acidic because of formation of H plus ion here, right? Let us see, this is the overall reaction. Anode reaction, H2O undergo oxidation, and cathode H2O undergo oxidation. At cathode H2O undergo reduction and H2O undergo oxidation in anode. And the overall equation when you write, look at this. To balance number of electrons, 4 electron must be equal to the electron gained here. Therefore, it is multiplied. Whole equation is multiplied by 2. And what you are going to find is 2 into 2 into 2, 4 H2O plus 2, 6 H2O, giving rise to 2H2 plus O2 and 4H plus ion and 4OH minus ion. 2 into 2, 4OH minus ion. 4H plus and 4OH minus ion is nothing but 4H2O, and overall reaction is 6H2O here and 4H2O here. Therefore, it is 2H2O, H2 plus O2. So you are getting the electrolysis of water itself. So electrolysis of water, whenever you are doing also you are getting the same product. But during the electrolysis of water, it is asked to put some potassium sulfate or some salt or dilute sulfuric acid. The product is not going to be changed because of electrode potential values of H2O is favoring the formation of H2 at cathode and O2 at anode. And by adding potassium sulfate for electrolyzing the water, we are increasing conductivity value of the water by the presence of the ions, and thereby we are increasing the rate of electrolysis. Right? So again we will see the different products of electrolysis of different salts. So during the electrolysis of aqueous sodium chloride, remember that there is a difference when you take molten and aqueous. Molten sodium chloride, when you take only sodium ion and chloride ions are present, therefore there is no option. That means sodium is getting deposited at cathode and chlorine gas is being formed at anode. But if you take aqueous solution, interference of H plus and OH minus ion also will be there. Now here sodium chloride, since it is consisting of sodium ion and chloride ion, and H2O is intervening at cathode, H2 gas is being formed, at anode chlorine gas is being formed. So when you electrolyte sodium chloride, aqueous sodium chloride, you will get H2 at cathode and chlorine gas at anode. These are the overall reaction. Now let us try to see from the point of view of electropotential why chlorine is being formed. Why not H2? Why not O2? H2 is formed at a cathode. Why not O2? So there is a slight difference in the electropotential values. So for the cathode there is no change. Sodium ion giving rise to sodium, the electropotential value is negative, minus 2.71. But whereas hydrogen ion undergoing reduction, the electropotential value is 0. Therefore 0 is more than minus 2.71. Therefore hydrogen gas is being formed. That means this half equation is being formed, or not this. Sodium ion will remain as it is in the electrolytic solution. So this is being formed. Now, since the later one is having higher electropotential value, this is being preferred product. Now at anode, here is the issue. So chloride ion forming chlorine has got reduction potential of 1.36 and H2O giving rise to O2, and this is 1.23. There is a slight difference. But accordingly, reduction potential is not to be compared here because oxidation is going on. You should change the sign of the reduction potential so that you will get oxidation potential. Oxidation potential is to be compared. But the reaction at anode with the lower value of E0 values, even though it is lower value of reduction potential is preferred or higher value of oxidation value is preferred, chlorine is being obtained rather than H2O. And this concept of this is due to overpotential or bubble voltage. So for the secondary reactions, the additional discharge potential which is necessary will make the chlorine to get evolved, not the oxygen, even though theoretically oxygen can be the product, but chlorine gas is being formed because of overpotential. So this is the anomaly, and you may remember that. The aqueous sodium chloride, whenever it is electrolyzed, hydrogen gas is evolved at cathode and chlorine gas is being formed. Now, so what is the commercial use of this electrolytical cell? Electrolytical cell is refining and electroplating. Refining and electroplating. So these are the two important areas we find its application. So impure metallic copper will be made pure by almost 100% copper by refining. And you can plate, you can do a coating of gold over copper by using these principles of electrolysis. Let us try to see. It is interesting how this exactly occurs. Now, as I told you, the electrolytical cell consisting of an electrolyte and an electrode. For example, we have taken copper electrodes in the copper sulfate solution. Right? So what you are going to find is these copper electrodes are active, then copper sulfate also undergo oxidation reaction, and when the DC source is being connected, so the electrons are being given to this electrode, which is called as cathode. So this is negative polarity. So negative polarity, so that the cations will move there and get deposited over here. So copper is get deposited over here, whereas this electrode anode, this copper undergo oxidation. Okay, so this is how you will find the product of electrolysis, right? So like this, anode copper is undergoing oxidation, therefore it becomes thinner and thinner by the loss of copper metal atom and converted into copper ions. And this is what happened at anode, and cathode, copper 2 plus ion will get the electrons to form copper. So this is get deposited over the cathode, and cathode becomes thinner and thinner, thicker and thicker. Now, there is no net reaction Net reaction is not there because copper from the anode is being given as copper ions to the electrolyte, and the copper ions in the electrolytes deposits over cathode. Because of this, impure one is made as anode. Impure copper is made as anode and pure copper is made as cathode. And what we find is, when anode gets oxidized, the copper into copper ions, the other reactive metals will be converted into its ions and they do not participate, and the precious metals will get precipitated at the anode, which are called anode mud. And anode mud consisting of precious metals like platinum and gold, and the cost of electrolysis is met by the anode mud. Now let us see how much is being produced. How much is being produced? That is by Faraday's laws of electrolysis. So know about how much is being produced. We have a law called Faraday's law, and it states that the amount of chemical reaction which occur at any electrode is directly proportional to the charges which is passing through it. Charges which is passing through the electrolytes. So this is called first law, and the quantity of the substance which is being formed is directly proportional to charges. Let us try to see the mathematical expressions of it so that you may understand in a far better way. Right. Okay. Now see, Faraday's first law says that mass which is deposited at an electrode is equal to mass deposited is directly proportional to charge. Mass directly proportional to charge passing through the cell, or mass is equal to Z into Q, where Z is a proportionality constant. Proportionality is converted into an equation by a proportionality constant Z. And also we know that charge is nothing but current in amperes and time in seconds. Okay. So if 10 amperes of current is passed through 10 seconds, 10 into 10, that will give 100 coulombs of charges which is passing through. So Q is charges which is given by Q is equal to IT. Q is equal to IT, therefore substituting M is equal to ZI. So remember that I should be in ampere and T should be in seconds, so that you may able to get the Q in coulombs. Okay. Now here, remember that there is a constant called 1 Faraday, whose value is nearly equal to 96,500 coulombs, 96,500 coulombs, and the Z is called electrochemical equivalent. Electrochemical equivalent. This value can be got by gram atomic weight by ionic charge. Gram atomic weight by ionic charge. You are going to get the equivalent weight, the Z value for a particular element. Right? So let us take some numericals based on the Faraday's law of electrolysis, and we will try to solve that. Now example 1, calculate the mass of palladium produced by the reduction of palladium 2 ions during the passage of 3.2 amperes of current through a solution of palladium 2 sulfate for 30 minutes. So here current of 3.20 amperes, current of 3.2 amperes is being passed to a solution for the time of 30 minutes. So this is important to mention that 30 minutes. You are asked to find out how much mass of palladium is being produced. So this is an electrolytical cell consisting of palladium ions, palladium is Pd, 2 plus ions, having some inert electrodes. You have to imagine all this, and with a source. Now this is negative polarity, palladium will go here and get deposited, right? Palladium 2 plus ion, to form palladium metal, so it needs 2 electrons. This is the key equation to be remembered. So here palladium 2 plus, gaining 2 electrons will form palladium. Now 2 electrons or 2 moles of electron will give 1 mole of palladium. 1 mole of palladium. So what is the molar mass of palladium? This is 106 grams per mole. It is the molar mass of palladium. So it tells you that 2 moles of electrons necessary for depositing, 2 moles of electrons will deposit 106 grams of palladium, right? Now we have to see how much charge is containing 2 moles of electron. You know that electron carry 1.6 into 10 to the power minus 19 coulomb, and 1 mole is equal to 6.022 into 10 to the power 23. So by multiplying this we will get Faraday, that is 96,500. Now 2 moles of charge carry 2 into 96,500 coulombs of charges. So this is to be taken in this way. 2 moles of electron carry 2 into 96,500 coulombs of charges. This many coulombs of charges will give 106 grams. Therefore, what is the charge which is current which is being produced? The charge which is passed is I into T, that is 3.2 amperes for 30 minutes. 30 minutes is to be converted into seconds. Therefore, into 60. Amperes and time in seconds will give you coulombs. If this much coulombs is produced, how much palladium is being produced? 2 into 96,500 coulombs of charges will produce 106 grams. This is obtained from this key equation. And this is from the question. If this much coulombs of charge is being produced, charge is being passed, then how much is being obtained? So this is being given by multiply these two divided by the first term, that is 106 into 3.2 into 30 into 60 whole divided by 2 into 96,500. 96,500. So this is the way we can able to do it. So 30 is here, 60 because we are converting into second, right? Then 3.20 amperes, 2 into 96,500 is the denominator, 106 is the numerator, and we get 3.16 gram of palladium. So answer is 3.16 gram of palladium. So you may use the key equation like this, or you may do it the same way. You can do it by using Faraday's first law of electrolysis, that is M is equal to ZIT. We can make use of this also. We will get the same answer. I will tell you how it can be done. The Z value is nothing but the equivalent weight. Equivalent weight is the atomic mass, the molar mass of that divided by charge. Molar mass divided by charge. Since palladium contains 2 plus charge, therefore 2, and you want it in coulombs, therefore 96,500. So this is Z value. So Z value will get per coulomb what is the charge. So equivalent weight per charge, per 1 electron. Then into I is 3.2 amperes, and time is 30 into 60. 30 minutes in seconds, it is 30 into 60. So this will give you the answer. The same thing is there in this expression also, you can see. Same thing is there in this expression. 106 is there here. 3.2, 30, 60, 2 and 96,500. So these are the things to be taken in this way, so that you are going to get the answer 3.16. You may apply the Faraday's law and take the expression and do it, or you can take the half equation and proceed in this way to get the answer. Now, coming to the another question. Calculate the volume of oxygen produced by the oxidation of water in example 1. In example 1, in the sense, the same current is being produced. Same current with same time it is being taken out. Okay. Now, volume of oxygen which is being produced. That is an interesting question. Volume of oxygen which is being produced. So let us try to take up. Say here, some salt solution may be taken, or water itself is may be taken, and so this oxidation of water takes place. Oxidation takes place at anode. So at anode oxygen is being coming, and you have to calculate the volume of oxygen gas which is being produced. Now always we want to a key equation for that. Now what is the key equation when water undergo oxidation? H2O giving rise to O2 and 4H plus ion plus 4 electrons. Right? So this is 2H2O giving 1 mole of O2 and 4H plus and 4 electron. This is the way the half equation to be remembered and to be written. So we find that 4 electrons are involved means 4 Faraday of charge is being involved. 4 Faraday of charge is being involved. Right? When 4 Faraday of charge is being involved, 4 mole, that is 4 into 96,500 coulombs of charge is involved. We need 4 into 96,000 coulombs of charge is for charges for getting 1 mole of oxygen. And we know that gram molar volume, 1 mole of any gas at STP will produce 22.4 liters. This is the information that we have to take. And 1 mole of O2 when needed to be produced, we need 4 moles of charges, that is 4 into 96,500 coulombs of charges. This many charges are required. 4 into 96,500 coulombs of charge is required to produce 22.4 liters of oxygen. Therefore, now what is the charge which is being passed when the 3.2 amperes of current passes through 30 minutes? That means 30 to 60 seconds. This many coulombs of charge is passing through. What is the volume of oxygen which is being produced? So how do you get this question? How do you get this N? So multiply this 22.4 into 3.2 into 30 into 60 whole divided by 4 into 96,500. Okay, when you do this, you are going to get the answer. You can see that 30 into 60, that is there in the numerator, 30 into 60, right? 3.2 is also in the numerator, 22.4 in the numerator, and 4 into 96 in the denominator, so that we get 0.334 liters at STP. So this is the way we have to get the volume of a gas which is being obtained if the gas is the product of electrolysis. Now let us check the understanding of you. How much charge is required for the following reduction? 1 mole of Al3 plus to Al. 1 mole of Al3 plus to Al. So equation to be written like this: Al3 plus to Al. Right? Aluminium is solid, this is ion. Now to neutralize, electrons are involved, it needs 3 electrons, right? It needs 3 electrons. Once you can able to write this, you have solved almost half of the question. 3 electrons is 3 Faraday of charges. 3 Faraday of charges, if it is asked in Faraday, or 3 into 96,500 coulombs of charges. which is being formed. 96,500 is 1 Faraday is equal to this much coulombs. Therefore, 3 into 96,500 coulombs of charge is required when 1 mole of Al3 plus is to be oxidized, reduced to Al. Right? Now, 1 mole of Cu2 plus to Cu. Cu2 plus to Cu, needless to say, Cu2 plus takes 2 electrons, therefore 2 into 96,500. Now, MnO4 minus to MnO4 minus to Mn2 plus. If this is the question. Okay, this is tricky question. Don't take this is a charge on Mn. So, you have to find out oxidation state of Mn. Suppose if it is X plus minus, okay, minus 2 into 4, this is equal to minus 1. So this is the charge present over MnO4 ion, polyatomic ion. But whereas oxygen is having 2 minus S charge. So the total charge should be minus 1. Therefore, this is the way we calculate the oxidation state. So X minus 8 is equal to minus 1. So X is equal to minus 1 plus 8, that is equal to 7. So MnO4 minus, in this Mn is present with plus 7 oxidation state. Plus 7 to plus 2, it is reduced. So how much electrons are needed? Therefore 5 electrons are needed. 5 electrons are needed. 5 into 96,500 coulombs of charge is needed. Therefore the answer is, after multiplication, we get this one. 5 into 96,500 is 4,82,500 coulombs of charges. You can try that. So let us take some more questions. How much electricity in terms of Faraday required to produce 20 grams of calcium from calcium chloride? So this is the question, application type of question. 20 grams of calcium chloride, from which you want calcium. So let us take ionic equation, calcium 2 plus 2 electrons giving rise to calcium. So this is the half equation to be taken. How much electricity in terms of Faraday required for getting 20 grams? So here it is given that 20 grams. 20 grams, how much is required? So let us see from this point of view. 2 Faraday of charge is required for getting 1 mole of calcium. 1 mole of calcium, if you know the molecular mass of that, atomic mass of that, this is 40 U. That means molar mass is 40 grams. 40 grams. Molar mass is 40 grams per mole. 2 Faraday of charges will yield 40 grams. To get 20 grams, now the question is simple. For 40 grams 2 Faraday, 20 grams half of it, that is 1 Faraday is required. So that is the answer. Right? 1 Faraday is the answer. This is the way that we have to do. Now, some exemplar question, more than one answer correct type of question. There may be more than one answer also will be correct. Right? So this is what will be happen during the electrolysis of aqueous solution of copper sulfate by platinum electrodes. That means you have taken copper sulfate. You have taken copper sulfate, right? You have taken copper sulfate, and in which there are copper electrodes. You have taken copper electrodes. Okay. Then copper is deposited at cathode. So let us mark this. This is minus, this is plus. So the cations move towards cathode. Therefore, this is cathode. Negatively charged one, cations will go. Right? So marking like that will help to really choosing the correct answer. So cation is Cu2 plus ion which will deposit. Therefore, copper will deposit cathode is correct one. Then copper will deposit anode is the wrong thing. Oxygen will be released at anode. And copper will dissolve at anode. So the electrodes are platinum. These electrodes are platinum. So when the platinum electrode is there, there is no chance of oxidation of platinum. Either this electrode should undergo oxidation, or copper, there should be okay, there should be OH minus ion which undergo oxidation. So it is aqueous copper sulfate, therefore OH minus ion anode will go here, right? OH minus ion, that means water should undergo oxidation, or the possibility is platinum should undergo oxidation. So platinum being inert electrode do not undergo oxidation readily, therefore OH minus ion will give O2. Therefore oxygen will be released, both 1 and 3 will be the correct answer, right? Now, electrolysis of KBr gives Br2 at anode, but Kf does not give F2. Give the reason. So the answer is in the point of electrode potential values. Please refer it and try yourself. This is a problem for practice. And also there is one question that silver is deposited at metallic vessel of surface area 800 cm square, passing a current of 0.2 amperes for 3 hours. Calculate the thickness of silver deposited. Thickness of the silver deposited. So you have to understand the mass of the silver deposited by using Faraday's law. Once the mass is known and the volume can be got. So because of the density is being given. By knowing the density, the volume of copper deposited can be got. By knowing the surface area of silver that is being used, you can able to find out the thickness. So thickness, answer is being given 2.9 into 10 to the power minus 4 centimeter. Just to see whether you get this answer or not, try yourself. Thank you for the patient listening and